Common mode properties. Let us now study the common mode properties of the differential pair with active current mirror. We assume gamma equal to 0 for simplicity and leave a more general analysis including body effect for the reader. Our objective is to predict the consequences of a finite output impedance in the tail current source. As depicted in figure, a change in the input CM level leads to, as you can see in this figure, differential pair with active current mirror sensing a common mode change, a change in the bias current of all of the transistor. How do we define the common mode gain here? Recall from chapter that the CM gain represents the corruption of the output. Signal of interest due to variations of the input CM level. In the circuits of chapter, the output signal was sensed differently and hence the CM gain was defined in terms of the output differential component generated by the input CM change. In the circuit of figure, on the other hand, the output signal of interest is sensed with respect to ground. Thus we define CM gain in terms of single-ended output component produced by the input CM change. ACM is equal to delta V out by delta V in CM. To determine ACM, we observe that if the circuit is symmetric, V out equal to Vf for any input CM level. For example, as V in CM increases, Vf drops and V out does, and so does V out. In other words, nodes F and X can be shortened. Figure A, resulting in the equivalent circuit shown. Figure A, simplified circuit of figure B, equivalent circuit of A. In figure B, here M1 and M2 appear in parallel, so do M3 and M4. It follows that ACM is similar to minus 1 by 2 GM34 parallel to R0 34 by 2 by 1 by 2 GM1 plus RSS is equal to minus 1 by 1 plus 2 GM12 RSS into GM12 by GM34. Where we have assumed 1 by 2 GM34 very much less than R0 34 and neglected the effect of R0 1 2 by 2, the CMRR is given by CMRR equal to mod ADM by ACM is equals to GM12 R0 12 parallel R0 34 GM3 4 1 plus 2 GM1 2 RSS by GM12 is equals to 1 plus 2 GM1 2 GM1 2 RSS GM34 R0 1 2 parallel to R0 34. Equation indicates that even with perfect symmetry, the output signal is corrupted by input CM variations. A drawback that does not exist in fully differential circuits of figure of chapter. The high frequency common mode noise therefore degrades the performance considerably as the source shunting the tail current source exhibiting a lower impedance. It is also instructive to calculate the common mode gain in the presence of mismatches. As example, we consider the case where the input transistors exhibit slightly different transistors. Figure A. How does V out depend on V in CM? Hence, the change at figure differential pair with GM mismatch. Notes f and x is relatively small. We can uh, compute change in ID1 and ID2 while neglecting the effect of R01 and R02. As shown in figure B, the voltage change at P can be obtained by considering M1 and M2 as a single transistor in a source follower configuration with a transconductance equal to GM1 plus GM2, that is mod Vp is equals to mod Vp is equals to mod V in Cm into RSS by RSS plus 1 plus GM1 plus GM2. Where body effect is neglected, the changes in the drain currents of M1 and M2 are therefore given by mod delta ID1 is equal to GM1 into delta V in Cm minus delta Vp is equals to delta V in Cm by RSS plus 1 by GM1 plus GM2 into GM1 by GM1 plus GM2. Delta ID 2 is equal to GM2 delta V in Cm minus delta Vp is equal to delta V in Cm by RSS plus 1 by GM1 plus GM2 into GM2 by GM1 plus GM2. The change delta I D1 multiplied by 1 by GM3 parallel to R03 yields mod ID4 is equals to GM4 into 1 by GM3 parallel to R03 delta ID1. The difference between current and the delta ID2 flows through the output impedance of the circuit, which is equal to R04 because we have neglected the effect of R01 and R02. Delta V out is equal to GM1 delta V in Cm by 1 plus GM1 plus GM2 RSS into R03 by R03 plus 1 by GM3 minus GM2 delta V in Cm by 1 plus GM1 plus GM2 RSS R into R0 is equals to V in Cm by 1 plus GM1 plus GM2 RSS into GM1 minus GM2 R03 minus GM minus GM2 by GM3 by R03 plus 1 by GM3 into R04. If R03 very much greater than 1 by GM3, we have delta V out by delta V in Cm similar to GM1 minus GM2 R03 minus GM2 by GM3 by 1 plus GM1 plus GM2 RSS. The compared to equation, a result contains additional term GM1 minus GM2 R03 in the numerator, revealing the effect of transconductance mismatch on the common mode gain. Thank you.